Alright class, today we're starting 3.1 and it is polynomial functions. There's a little bit of stuff I need you to write down here. I'll go through it and then if you need more time you can just pause the screen. Standard form of a polynomial, you guys have been working with polynomials, quadratics, linear lines, all those are forms of polynomials. Just means many different terms strung together. The order that it happens is we usually write standard form in descending power order. So powers go from highest to lowest. The coefficients in front of the x's, so the numbers, are real numbers. And in order for it to be a polynomial, the x's have to be raised to positive integers. Okay? Now, if I say what's the degree of the polynomial, you tell me the highest exponent you see. And then the leading term is the term with that highest exponent. And then the constant term is the one with no x. So again, if you need more time to write that down, which you probably do, pause the screen now or go back a little and pause it. And I'm going to move on. Okay, so, oh, and I would move on if it, hold on, there it goes. Write the polynomial in standard form, if not already, then state the degree, leading term, and constant. So if we look at this, this has, all the powers are in descending order, they're all positive integers, and the coefficients in front are real numbers. So this is a polynomial in standard form already. So it's already in standard form. So I need to write the three things. I need the degree. And again, the degree is the highest power. So the degree would be 3 for this one. The leading term. Notice how I say leading term and not leading coefficient. I want the whole term. So the first term is 4x cubed. If I said leading coefficient, you would tell me it's just 4. And then finally the constant term is the one without x. And hopefully you guys see that it's the number 2, because that's the one that doesn't have an x. Alright, this one here is not in standard form, so we have to FOIL, or actually this would just be distributing. So we get x minus x squared. So I'm going to rewrite it in standard form where the negative x squared goes first, because it has to be in descending order. It is a polynomial because, again, if it meets the criteria. The degree for this one is 2. The leading term is the first term here, which is negative x squared, and there is no constant term. Or you could say it's 0, either way. Now if we look at letter C and we simplify this, we get f of x is equal to 2 over x. If you rewrite this with an exponent, remember when you have exponents that are negative, you bring them up, we get that. This is not a polynomial because it has a power that is not a positive integer. Okay? Now, factored form of a polynomial, you guys saw this when we did factored forms of quadratics. It's the function, some constant, or some value that will stretch, compress the graph, change the shape of it, and then all the intercepts. Remember, these are all zeros of the problem. So n is equal to the number of zeros, or degree. And then again, these are zeros, or intercepts. Okay? So if we look at this next problem here, it says what are the zeros in degree of f of x given? So we look at this. I have 1, 2, 3 x's with no extra powers. So I'd say the degree is 3. Because if you would multiply that all out, you'd have x cubed. And then the zeros are negative 1, 2, and 3. It's what makes each one 0. To get those, you just set each piece equal to 0. Okay? These are also technically your x-intercepts. If I said what are the x-intercepts, I'd like those as points. If I say zeros, though, you can already just tell me the numbers because it's already implying that it's a 0. So that is how you do that in factored form. This one is write the polynomial in factored form, and let's see what happens. So this should actually say x squared right here. So if yours does not say that, it needs to have a squared. It's 7x squared, or else we can't do this problem. So two numbers that multiply to 12 that add to -7 would be -4 and -3. Now, because it's x to the fourth and x squared, these both are x squareds. And then we can factor this piece more because it's a difference of squares. So we get x plus 2, x minus 2, and then x squared minus 3. This one here, remember when there are 4 pieces and it's a cubic, we try to do grouping, which means take what you can out of each of the first grouping and the second grouping. So first grouping, I can take an x squared out, and I'm left with an x minus 3. The second grouping, I can take a -4 out. Always take the negative out, and then you get x minus 3. Sure enough, you guys should see that this and this match. So we take those, and then we take this piece and this piece, and we make our two factors. So it's going to be f of x is equal to x minus 3, and then x squared minus 4. And again, it's not completely factored because we have, a difference of squares. So hopefully you guys get really good at seeing that pattern. It's if two things that you could take the square root of and a minus sign. You should be familiar with this now at this stage of your mathematical career, so hopefully you know that. So I see the same thing on C. I see 4 pieces with a cubic, so I think, oh, I've got to group this. Now, sometimes we can't factor it. Let's see what happens here. I take an x squared out, and I'm left with a 2x minus 1. Don't forget the 1, by the way. You have to do that. I take a 2 out, and I'm left with an x minus 1. Notice how these do not match. That means grouping does not work here. So in order to divide this and factor it, we would need a 0, which we don't have. And we'll learn that later. But for now, we can't factor that. Okay, so this is factored form, this is factored form, this doesn't factor. Or it doesn't factor by hand. We would need help with the calculator or our 0. So multiplicity. It basically is asking you how often does a 0 show up. So if some 0 shows up more than once, here's what happens. If you have an even multiplicity, which means you have an even number of that one 0, we'll say that's a multiplicity of 2, for example. What it looks like on the graph at the x-intercepts is that the graph will, let's say this is my 0 that has a multiplicity of 2, it'll bounce or just touch. So it touches, or you can use the word bounces. If it's an odd or if it's odd, which is a multiplicity of 1, for example, then it would look like this. And when you hit the 0, it'll go through. So we say it crosses. Okay. So let's take a look at how we can use that information to help us with the next 2 examples. Alright, so these shouldn't have e's. What are the zeros in degree of that? Well, hopefully you guys see that the zeros are at -4, and it has a multiplicity of 1, so it crosses at -4, 0. And we also have a 0 of -3, but this one has a multiplicity of 2, because remember, if it's squared, that's like saying x plus 3 times x plus 3, so the 0 happens twice, which means it just touches at -3, 0. But since this is a multiplicity of 2 and a multiplicity of 1, the degree is degree of 3. We're going to look at the graphs on the next lesson, so we won't have to worry about that until tomorrow. So write an equation with zeros at 2 and 0. 0 has a multiplicity of 2, negative 2, 0, and 2. That passes through the point negative 4, 576. So I'm going to write it in my intercept or 0 form. I don't know what a is. It's kind of like when we had vertex form for the quadratic. I have x plus 2 is from this one. That has a multiplicity of 1, so I'm good. I have x, but it's squared because it has a multiplicity of 2. And I have the factor x minus 2, and again, that's just degree of 1. So to find the a value, you just have to plug in this point over here that I gave you into, this is your y, and this goes in for all the x's. So you get 576 is equal to a times negative 4 plus 2 times negative 4 squared, which will be 16, times negative 4 minus 2. If you multiply negative 6 times 16 times negative 2, you get 192, and then times a equals 576. And now it's pretty easy to solve. You get a equals 3. So f of x is equal to 3 times x plus 2 times x squared times x minus 2. This would be the polynomial in factored form. Remember, this is not standard form. If I would have asked for standard form, unfortunately, whoa, what's going on here? Unfortunately, you would have to then FOIL this all out, which would take a little longer. So, all right, that is what polynomials are, and some properties of them, and finding the zeros in multiplicity. Tomorrow we'll do graphing.